In this video on coordinate geometry of the line, we'll be looking at different types of questions involving points on a line. We'll be verifying that a point is on a line, and we'll be finding unknown coefficients in the equation of a line when we know a point on the line. So we'll start by verifying that a point is on a line. And the first thing that I'd like to note is just that word verifying. What does it actually mean? Well, it just means to check that a point is on a line. And you may see a question worded as verify a point is on the line, but it might equally say check the point is on the line, or show it's on the line, or prove it's on the line. In each of these cases, we'll basically do the same thing. And our method for all of them is simply going to be to take the point we're given and sub it into the equation of the line. And there's a couple of different outcomes that can occur as a result of this. We can get a true result, and if we get a true result, that tells us the point is on the line. And if we get a false result, the point is not on the line. So let's look at an example now to see what I mean by this. So our example is to show that the point 1, 1 is on the line 2x plus 3y minus 5 equals 0. So first I want to sub the point into the equation. Remember that our point is made up of an x value and a y value. So I'll be using those to replace the x and the y in the equation. So that'll give me 2 times 1 plus 3 times 1 minus 5 equals 0. And then I'm going to work that out. And I can actually stick the entire left-hand side of this equation into my calculator, and it's going to give me a result of 0. So the left-hand side comes out as 0. So 0 equals to 0. Well, now what I'm looking for is to see if this result is a true result or a false result. So what I want to know is, does 0 equal 0? Well, clearly that's true. So I'm almost there, but not quite done yet, because I have to answer the question. I have to say, do I think the point is on the line or not? So I'm going to say that this result implies that 1, 1 is on the line. So now here's a second example. So this time we're asked to check if the point minus 2, 3 is on the line 3x minus 5y plus 2 equals 0. If you've got a good idea of how to proceed, give it a shot, pause the video and play to see if you're correct. And if you want to work through it with me, that's fine too. Okay, so I want to check if the point is on the line. Well, what I'm going to have to do so is sub it in. And of course, I know that my point is made up of an x and a y part, and they're going to get subbed in for the x and the y in my equation. And when I fill those values in, it'll look like this: 3 bracket minus 2 minus 5 bracket 3 plus 2 equals 0. And then again, I can go to my calculator and just stick in this whole left-hand side to see what I get. So on the left-hand side of my calculation, this time I get minus 19, and this equals 0 is just the equal 0 from here on the previous line. Now again, I need to decide, is this a true result or a false result? Well, okay, it's fairly obvious here that minus 19 is not equal to 0. So I'm going to state that, and then I'm going to note my conclusion. So this implies that the point minus 2, 3 is not on the line. And it's just really important to note that you're not finished until you write this line down. So your calculation is important because it'll tell you what the answer is supposed to be, but you have to give the context at the end. You have to give your interpretation or your conclusion to finish the question fully and get all your marks. Okay, so now a question for you. So verify whether the point 0 minus 1 is on the line x minus 2y plus 2 equals 0. Pause the video here while you go about this and then play to see if you're correct. Don't forget to give your concluding line at the end of your calculations. Okay, so I know that my point has an x and a y. I'll replace the x and the y in the equation with that. I'll use the calculator to evaluate the left-hand side. I'll clearly note whether my result is true or false, and in this case it's clearly false, and then I'll state my conclusion. So this implies that the point 0 minus 1 is not on that line. So your question is to prove that the point 1, 1 is on the line y equals 3x minus 2. So again, pause the video here while you do this, and then play to see if you're correct. So again, I'm just noting that my point is made up of an x and a y. So I'm going to substitute the values in the point into the equation. I get 1 equals 3 times 1 minus 2. There's nothing to do on the left-hand side, but I can evaluate my right-hand side. And when I do that, I get 1 equals to 1. So I'll note whether it's true or false, and then I'll draw my conclusion. So the result that I got implies that the point 1, 1 is on the line. And you'll notice here from the examples and questions that we've done that the format of the line doesn't actually make any difference. So it can be in the form ax plus by plus c equals 0. It can be in the form y equals mx plus c. It could be in some other jumbled up format. And regardless, what I can do is I can just take the point, sub it in. If it's true, the point is on the line. And if it's false, the point is not on the line. So now let's move on to the second part of our video. So this is finding unknown coefficients in the equation of a line when I know a point on the line. These types of questions will start in a really similar way to the previous examples and questions that we've seen in this video. So we're talking about points on lines, so it's going to involve subbing the point into the equation. And the main thing to bear in mind with these kinds of questions is that the point that I'm going to be given will be on the line. I'll be told the point is on the line. And if that's the case, that's really useful because it means I know I'll get a true result when I sub the point into the line. So let's look at an example. So here's an example of this type of question. The point 1 minus 1 is on the line ax plus y minus 2 equals 0, and we want to find the value of a. So we don't know the value of the coefficient of x, but we do know that the point 1 minus 1 is on the line. So, like I said, we'll take the exact same approach as previously. We'll say this is the x and this is the y, and we'll replace the x and the y in the equation with those. So I'll have an equation like this. I've put a bracket around each value that I've substituted in there, and I can tidy it up now a little bit. And bear in mind that I know for a fact that this equation is true because I've been told the point 1 minus 1 is on this line. So as a result, to find the value of a, all I have to do is tidy this up and solve for a. So how will that look? So I'll expand my brackets first of all, and then I'll get the a by itself on the left and the numbers on the right. Since I have like terms, I might actually put those together first of all. So 1a minus 3 equals 0, and then 1a equals 3. And of course, we know that 1a and a are the same thing. So at this stage, I have my solution. A is equal to 3. So here's your question. The point 1 minus 3 is on the line 4x plus by plus 2 equals 0. Find the value of b. Pause the video while you do that, and then play to see if you're correct. So again, I'll label my point xy, and I'll substitute those values in for x and y in the equation. And when I substitute that in, it looks like this. 4 bracket 1 plus b bracket minus 3 plus 2 equals 0. So now I want to multiply that out, and I can put my constants together, and then I'll keep my variables on the left and my constants on the right, and I'll divide across by minus 3 to get b. So in this case, b is equal to 2. This type of approach can also work if I don't know one of the values in my point, but I have my line in full. So for example, here I've got the point 2k, so I don't know this value, but I do have the full equation of the line 2x minus 5y plus 1 equals 0. So to find k in this case, what I can do is, again, I can just call my point x and y, and again, just substitute the point into the equation. So in this case, I'd have 2 times 2 minus 5 times k plus 1 equals 0. And then again, it's just a question of figuring out the value of k from your equation. So I'm going to multiply out. I'll put my constants together. I'll keep my variables on one side, and then I'll move the constant to the far side. And then I'll divide across by minus 5 to get k. So in this case, k is equal to 1. Just to put that solution in context, what it means is that the point 2, 1 is on the line 2x minus 5y plus 1 equals 0. Okay, let's finish up so with a question for you. The point p minus 2 is on the line x minus 2y minus 3 equals 0. Find the value of p. Pause the video here while you do that, and then play to see if you're correct. Okay, so I'll label my point xy, and I'll substitute that in then for x and y in the equation. So we've got p minus 2 times minus 2 minus 3 equals 0, and then I'll just tidy that up a little bit. So we have p plus 4 minus 3 equals 0. Putting my constants together, I've got p plus 1 equals 0, and then I'll keep p on the left and push the plus 1 over to the far side. So my solution there is p is equal to minus 1. And again, just to put that answer in context, that means that the point minus 1 minus 2 is on this line x minus 2y minus 3 equals 0.